So examining the Bohr model is quite straightforward. When a sample of any pure element or compound is taken in the gas phase and put in what's called an emission tube, it can be excited using an electric current, and we see a bright light. This is like a neon open sign on a restaurant or something. If you actually go and you take that light, that pure light, and you use a prism or some sort of diffraction grating, we can actually split that light into its constituent wavelengths. And what this is electrons jumping between orbits, as would be indicated by the Bohr rings. So as we can see here in the cartoon on the right, we see this would be the emission spectrum for hydrogen. So when hydrogen is excited, we split the light, we see these four lines. So the Bohr model tells us that the electrons for hydrogen and helium would sit together in the first ring, and that, in fact, when excited, they should produce the same emission spectrum. Okay, so this is a simulator. This is the hydrogen emission spectrum. As you can see here, the four lines, but when I click on helium, we actually see a great deal more lines. So what is this telling us? Okay, if I go through lithium, beryllium, boron, all the way through to neon, I'm going to see there's all kinds of different lines. So everything on the second row, all of those electrons should sit on the same ring. As you learned the Bohr model, 8 electrons on the second ring. They actually don't produce the same spectrum. So there has to be something more going on inside an atom. So what we find is, in fact, that the Bohr model isn't quite enough to explain what's going on. So this will lead us to what's called quantum mechanics. Feel free to have a look at that web address there if you want to play with the simulator yourself.